In last video, we are discussed about the formation of steam. In this video, I am going to explain the steam formation at constant pressure with temperature versus enthalpy graph. So let us consider. So we already know that the steam exists in three forms. The form of steams. So first one is called as wet steam. Second one is dry steam. Third one is superheated steam. The steam we are classified three types. One is wet steam, second one is dry steam, third one is superheated steam. In a wet steam, the steam contains both water particles as well as gas. It includes water and gas. So here in a dry steam, the water particles are negligible, so that in a dry steam it contains only the gas. And also in superheated, it contains only the gas. So in a dry steam, it is acted as a perfect gas. We already discussed these things in a previous video. So here we are consider the temperature and the enthalpy. So these two terms are explained by referring temperature versus enthalpy diagram. So let us consider a x-axis and y-axis. Along the x-axis, I am considering the heat, or we call it as enthalpy or heat. Along the y-axis, we are considered heat. So let us consider the point O. This point is an initial point of a water. So here the water, it is in a liquid form or it may be in solid state. Now we are going to supply a amount of heat into a water. So we are considered 1 kg of water in a cylinder. When we are supplying the amount of heat into a water, then the water absorbs the heat and also increases its volume and as well as temperature. When the temperature increases, the volume of the gas is also increases. So here this is an 0 degree Celsius. Let us consider this is an 0 degree Celsius. When we are supplying amount of heat, then the temperature of the water goes on increases. Means the temperature is directly proportional to the amount of heat is supplied. So this is considered point 0 to the point 1. The 1 point is called as boiling point or saturated temperature. This is called as saturation temperature. Means the amount of heat is absorbed by the water, it's converting into or it starts to boiling at a temperature point of 1. So this temperature is called as saturation temperature. This is called it as saturation temperature, where the boiling starts is called as saturation temperature. Next, according to this means the point 1, from point 0 to the point 1, the amount of heat is absorbed. The absorbed heat, this heat is called as sensible heat. So this is considered as H of F, amount of heat or enthalpy of fluid. So here in an 0 degree Celsius, the water in an solid state, it is gets converting into the liquid phase. So in an 0 degree Celsius, the water is an solid state. When we are supplying amount of heat, it starts to converting into an liquid. So from 0 degree Celsius, the boiling point of the water is 100 degree Celsius. Let us say 100 degree Celsius. It is called as saturation temperature. Means 60 degree to 100 degree Celsius, the water starts to convert into an steam or vapor or steam. So below the 100 degree Celsius, we are called as vapor. It is the complete mixture of liquid as well as gas. Behind 100 degree Celsius, we are called as steam. So from point 0 to 1, it is considered as an vapor. Okay. So here the solid state is completely converting into the liquid state. That is called as sensible heat. Means the amount of heat is required to convert, or it is reaches to its boiling point. That is called as sensible heat. Sensible heat means the amount of heat is absorbed when 1 kg of water is heated at a constant pressure from 0 degree Celsius to the formation of the steam. The temperature is formed as steam. That is called as sensible heat. So sensible heat, it is represented by H of F. H of F is equal to 1 kg of amount of heat, 1 kg of water is converting, or he is heated at constant pressure. At constant pressure from 0 degree Celsius, to boiling point, or the temperature of formation of steam. That is called as sensible heat. Sensible heat means the 1 kg of water at a constant pressure. Let us consider 1 kg of water at a constant pressure. It is converting, or from 0 degree Celsius to its boiling point or saturation temperature, is called as sensible heat. Next, once again we are supplying some amount of heat, the saturation temperature remains same, because from point 1 to 2, it is considered as an latent heat. So this is considered as an latent heat. Here the amount of steam or the liquid form is converting into an steam formation. This steam having an amount of water particles as well as gas particles. Means it is the mixture of water vapor as well as gas particles. So that it is called as wet steam. So here we need to convert, completely converting into dry steam. So the water particles are completely converting into gas. This stage is called as latent heat. This amount of heat is called as latent heat. Means in an saturation temperature, the amount of heat is required to convert complete conversion of, or completely converting of wet steam into the dry steam. That is called as latent heat. Latent heat is denoted by HF of G. HF of G means latent heat, amount of, here the amount of heat is absorbed, to evaporate 1 kg of saturation water or 1 kg of water from an saturation temperature without any change in temperature. Means latent heat is denoted by HF of G. So here 1 kg of water of its saturation temperature or from its saturation temperature, T saturation temperature, it is converted without any change in temperature or no change in temperature. The amount of heat is observed to evaporate 1 kg of water at its saturation temperature without any change in the temperature is called as latent heat of vaporization. And also when it reaches its point 2, behind it point 2 means it is an saturation temperature. Above the saturation temperature is called as superheated temperature. From point 2 to point 3 is called as superheated temperature. So this is called as superheated temperature. Superheated temperature. So from point 0 to 1 is considered as a sensible heat. In this sensible heat, the amount of 1 kg of water is converting from 0 degrees Celsius into its saturation temperature, or it is called as boiling point. Or in an saturation temperature means here the water starts to converting into the vapor. That temperature is called as saturation temperature. Next, point 1 to point 2 is considered as latent heat, that is denoted by HF of G. So in this heat, the amount of water or 1 kg of water from an saturation temperature, it is absorbs. The 1 kg of water is absorbs the amount of heat to evaporate without any change in the temperature. That is called as latent heat. So when we are increasing the temperature above the saturation temperature, the amount of heat is converted into an superheated temperature. This portion is called as superheated temperature. So the temperature is called as superheated temperature, heat is called as superheated or heat of superheated temperature. So next, let us consider the terms, important terms we are considering in an formation of steam. Next point is dryness fraction. Dryness fraction. Dryness fraction, it is denoted by small letter x. X is equal to, means here dryness fraction means the amount of actual dry steam is presented in a wet steam, that is called as dryness fraction. So here x is represented as dryness fraction. Dryness fraction can be calculated by mass of the gas divided by wet steam. Total wet steam means m of G plus m of F. M of G is represent mass of the gas, m of G is mass of the gas, and m of F is mass of the fluid. So the mass of the gas and mass of the fluid is called it as total wet steam, or the mass of the total mass of the wet steam. Dryness fraction can be defined as it is the ratio of mass of the actual dry steam with respect to the mass of the same quantity of wet steam. This is called as dryness fraction. Next, degree of superheat. Degree of superheat. Degree of superheat, it can be defined as the difference between the superheated temperature and saturation temperature. Superheated temperature minus saturation temperature, it is the difference. difference between the superheated temperature as well as saturation temperature is called as degree of superheated.